Hello, my name is Wiyanda Aflah. I'm a PhD candidate at the University of Sydney working with the Malone Institute. My research explores regenerative agriculture impacts and opportunities specifically related to hydrology. In simple terms, I'm asking, can regenerative agriculture really help rehydrate our landscapes? Regenerative agriculture uses management practices that aim to restore landscape function and support agriculture production. My PhD approaches this topic through two questions. First, what does the evidence tell us about the regenerative agriculture and hydrology? Second, how can we determine whether these practices are genuinely changing the catchment water cycle? My main study area is the Malone catchment in New South Wales, where leaky weirs have been installed. These are small structures made from natural materials that slow stream flow and retain water within the landscape. I combine evidence mapping, data-driven analysis, physical modeling, and process understanding to move from identifying what is known to measuring change and ultimately explaining why that change occurs. This matters because agricultural landscapes are increasingly degraded, reducing productivity, ecosystem function, and resilience to drought. Regenerative agriculture is often proposed as a solution, but water remains the missing link in the evidence. The main challenge lies in distinguishing true management effects from natural climate variability in complex catchments. So ultimately, better evidence and process understanding can help basin stakeholders such as farmers and government agencies to target regenerative agriculture practices where they are most likely to deliver meaningful benefits. So far, my systematic map has identified limited catchment scale hydrological evidence, with several regenerative agriculture practices still underexplored. Using a data-driven framework, I found that leaky weirs increase actual evapotranspiration across the floodplain by approximately 18%, indicating greater water availability for vegetation. My research showed that hydrological processes shift and interact dynamically under contrasting climate conditions. This non-stationarity makes it difficult for both data-driven and physics-based models to separate true management effects from climate-driven change. Currently, I'm now examining leaky weirs' effect on stream flow and developing scenario-based models to evaluate how scaling up regenerative agriculture could alter the wider catchment water balance. The key message of my PhD is hydrological responses to regenerative agriculture are highly dependent, and effective implementation requires right practice in the right place. Thank you for listening.